Hi, my name is Glen, and today I present to you the story how we at OTA Insight managed to grow to over 100 million daily requests from around 300 different data sources. OTA Insight is a company within the hospitality industry where we help managers and other people to make smarter decisions. Within the hospitality industry, we as a crawler team care about any data related to the hotel industry, meaning hotel rates, hotel rankings, review scores, and events. The typical customer is, for example, a revenue manager. And what often happens is they come into their office and they want to see how are they doing and how are their competitors doing and what kind of decisions they need to make that day to make the best for their revenue. This can be within the web application or as well an Excel sheet that we send them in the form of reports. Now, these revenue managers are spread around the world on all these different time zones. So what the morning in Europe is of course not the same time as the morning in the United States. As such, since the beginning, we already isolated our crawler batches, split up according to the different time zones. This allowed us to have different workloads for different time zones and have at least some kind of separation right since the beginning. Now, let's talk a bit about data, because of course, what data means is different for any industry. Right from the beginning, we knew that we wanted to use Scrapy. We knew that we had to extract data and apply some transformations to it, meaning we have to go to the data source, extract the data, transform the data, clean it up, and then export it to some kind of format. Now, the problem is, in case you do this extraction and transformation within the same process, it means also that in case you made a wrong assumption during the cleanup and transformation pipeline, you will need to redo the entire process, meaning you will have to go back to the data source and will have to once again extract the data. That's a bit of an issue. So, since the beginning, we split up the transformer stage from the crawler stage. This gives the advantage that the crawler can stay as simple as possible and focus on what it does best, extracting the properties of the data sources we care about. It will simply extract these and with as little logic as possible, send this information to the transformation stage where we actually validate our assumptions and do any transformations, meaning transforming a single property, combining properties, and doing any kind of cleanup. By doing this, we are now able to correct our wrongly made assumptions in case these happen without having to go back to the data source and instead rely on a temporarily stored backup of this intermediate data. Now, let me show you a bit how this looks like from a process point of view. So we always start with some kind of input. How exactly the input looks like is less important at this stage, but most important is that it defines to the crawler what it needs to extract. It is then the crawler which extracts the properties we care about. And here we do want more rather than less, because you never know what other properties you do want in the future. It is these properties which are then extracted and exported in some kind of intermediate format, for example, JSON. And this data is sent to the transformation stage, which then transforms it into a very standardized format. This format is data source agnostic and is already cleaned up data. It is also this data which then a lot of teams use in the application, but also for analysis. We have different kind of data points such as rates, ranking, and so on. Now, let me show you a bit how this looks from an infrastructure point of view and how we basically started. We had our CSV inputs, which were at this point giant files, and we stored them in network storage. You can think of them as a single input per time zone. These were used by our Scrapy daemons, which run on a virtual machine within the Google Compute Engine, which extracts our data source usually via a proxy. The documents it fetches could be HTML, JSON, and so on. These documents are also stored for a very short time on a temporary file storage, allowing us to debug any issues in case we are not able to extract data while we were expecting it to do so. We also export a temporary backup of the data it will send to the transformer. In the beginning, we used to send this over Kafka to a transformer, which is another process, another workload, and we used to do it over Kafka. Now, in case we want to do a reprocess, meaning we had a wrong assumption and we want to redo the transformation pipeline to get the accurate data, we no longer need to go via Scrapy, but instead we can simply extract or fetch rather the data from our temporary file storage. And finally, it is a transformer which writes the final rate information or ranking or any other kind of final information to Bigtable, where finally, of course, it will be consumed. Now, all this was good, but it also really wasn't. Like, it was very error prone. We had to manually configure all these, well, you couldn't call them deployments, more like processes within virtual machines. There was some kind of minimal optimization, but it was almost not existing. When something went wrong, we had no overview. So we were like chickens without heads. And a retry was very costly because, as you can imagine, these were giant CSV files. So one input is really a lot of different jobs. As such, we introduced in 2015 integrity's concept. We're going to go over the different components of this concept one by one, but it's also important to know that an integrity is basically a single job assignment, meaning is a single kind of booking configuration for a single kind of hotel on a single data source. This allows us to identify and track a status per integrity, which we stored in a MySQL database. In the beginning, an integrity would be missing because we didn't crawl it yet. Now, ideally, after a while, and ideally before deadline, it is complete. But if not, there will be some kind of error status. And the beauty of all this is that we now have an overview, and we can even auto-retry on failures because we have now a pretty granular process. We also introduced the concept of grouped integrities. This allowed us to automatically trigger actions based on some kind of rules. For example, we could say that a report would be for a hotel, a customer, for getting an overview of the rate information of all the different rates available for the hotel, as well as its competitors for the next 90 days. We could say that as soon as 70% at least is complete, to allow some kind of error marge, that the report can be generated. And it will be then generated automatically by triggering the action, which is triggered based on this threshold. And this way, the revenue manager can check his data right on time. We also introduced some kind of scheduler, which was at this point a GUI, which allowed us to do high-level cross-VM configuration and also have the ability to orchestrate on a higher level. This was beautiful because now we no longer had to manually go into these virtual machines, and instead we were able to do a lot of common actions right from within this GUI. We were at this point already at a much higher scale in the beginning, so it was definitely more than welcome. Now, our revenue manager checks his web application, and it is all fine. Most hotels will only shop in the morning, some also afternoon and evening. Now, what happens if the revenue manager is updating their rates between the morning and afternoon? They will see it within the live data source, but they won't see it being reflected within our application. As such, we introduced the concept of live shops. And live shops allow the customer to trigger a button to fetch data at the click of a button. This could be for a single month, but it could also be for a single day. And for some power users, it could also be for an entire report. This, of course, has its challenges. First of all, we never know when to expect this live shop because, well, it's based on an action of a user. So we always have to be ready. Now, in order to be ready, we also don't want to all the time have the full capacity workload for each different data source, because that would not be very cost effective. So we needed to be able to scale automatically. We choose to do this by moving the scrapies for the live shops to Docker-based workloads. This way, we were also able to utilize G-Cloud feature to be able to scale automatically based on the resource consumption. We also moved our inputs from CSV to protobuf and sent these directly to the crawlers. Around this time, in 2016, we also introduced Super Proxy, which is a man-in-the-middle HTTPS proxy written in Golang. It was designed for high traffic, and we mostly wanted it to be able to traffic all the outgoing traffic, to be able to know how much data we are sending to these sources, how much we are sending back. Also are able to know which status codes are being sent back, which proxies are doing good, which not. Another task this allowed us to delegate to was to make it go all our traffic to our different proxy routers. Because prior to this, we were going from our crawlers directly to our proxy providers, but this meant that every workload had to do it themselves. Now instead, our super proxy could do this all for them. Only later, we also started using it for emulation of HTTP and TLS fingerprinting. We also introduced an internet browser, because sometimes a website does not have a direct link that allows you to get the data that you want. This could be because you have to fill in some kind of very complicated form, or there is a lot of web client requests required that it normally does via JavaScript. In this case, we required the browser. At the time, Splash seemed like an excellent solution for us, and we already knew the company that made it because it's the same company behind Scrapy, so we choose for that one. So let me show you how this changes in the last 3 years between 2013 and 2016 impacted our infrastructure. We had our MySQL database for status tracking. We had our scheduler, which now sits in between our inputs and our Scrapy workloads. And of course, our Scrapy workloads are now also divided in 2 different kind of workloads. We still have the VMs, but for live shops, we have now the Docker workloads. We also switched to BigQuery, which was a very impactful change for a transformation stage. It was very helpful for our querying stage for developers. We also had to move away from Kafka to PubSub in order to make the Scrapy live shops work. Finally, we also introduced Super Proxy, and optionally for those workloads that require it, we also first go via Splash, which is a separate workload as well. Now, at around this stage, we were reaching around 20 million requests per day, which is still a lot less than today, but we knew we had still a lot of growth march. A year later, we already replaced Splash with Puppeteer. The main reason was that the rendering engine of Splash was pretty outdated and easy to detect, allowing data sources to block us pretty easily. The fact that we had to interact with Splash via a very awkward Lua interface did not help as well, because in the end, a browser API is JavaScript, so it might make more sense to do your entire automated browser in JavaScript as well. Now, we already talked a bit about having automatic error handling. We talked about the fact that we were able to automatically retry integrities, and that we could also reprocess things that we detect, like if we made wrong assumptions. Of course, we are at this point at the giant data scale that we are no longer able to check all these different data points manually. So we need to be able to detect any kind of wrong assumptions, any kind of mistakes on our side very quickly. And sometimes, of course, these are also mistakes from the data source themselves. Luckily, we have all this data at hand. And so we are able to see if a certain property of a certain data point is suddenly very different than what we expect. A very clear example of this would be that a given data source suddenly have almost all our data points marked as sold out, even though normally we only expect 30%. Thanks to the anomaly detection, which is a different kind of process, or rather a collection of processes, we are able to detect this and trigger alerts. And by doing this, we are able to fix our data prior to the fact that customers will ever able to see this. Now, at this point, our client data needs were growing exponentially. Infrastructure suffered from legacy creep, and each time we need like a new business need, it was harder and harder to integrate into our infrastructure. So we knew we had to do something. And we decided that it was time to move on to a new concept. After a lot of iteration, after all the developments, and 6 months of efforts across many different teams, including the backend, DevOps, and so on, as well as the front end, and probably many other teams I forget, we created Integrities V2. This was a very big effort, and it really forced us to basically lock down on any other features across the company in this period. But it was worth the effort, and I can tell you that even still today, we are making use of this infrastructure. Visually, you can see the result here. Not only is our dashboard much cleaner, but you can also see that most of our shops are now succeeding. This is because we have a lot of more tools at our hands, and the system is designed much more smartly. We have a lot of different dashboards and can check out as granularly as possible our different stages of our pipeline, which makes the life for the developer pretty easy. Now let's talk a bit about the different components that make up this Integrities V2. First of all, we replaced MySQL with FoundationDB. This was important because MySQL was no longer able to handle our load. We have a lot of atomic writes at scale, and MySQL simply couldn't handle it. We also looked at Bigtable, but this had no atomic features, certainly not at the time. So after a lot of testing, comparing different solutions, and in the landscape of database in 2018, we settled on FoundationDB, which turned out to be the right tool for the job. And even today, it still can handle our load, even though we grew massively once again. Now, database landscape changed a lot in the meanwhile, and it's very possible that if you do the same exercise today, that you might land on a different solution. Nevertheless, Foundation would work as well. Now, we also learned a lot from our Kubernetes workloads for scrapers for live shops. And we knew we wanted to scale automatically our scheduled shops in our new system. So we also moved the regular scheduled crawlers to Kubernetes, and we dropped the entire CSV input from the pipeline and moved everything to Protobuf. We also introduced a planner and a scheduler, not to be confused with the scheduler I mentioned before. The planner is there to forecast and simulate any kind of like workload it might be expect to be able to do, because it knows it's based on the historic data, and it knows also based on what kind of workload it needs to be done against a certain deadline, which is still time zone based. The scheduler takes information into account which the planner has generated, and will also take into account all the input generated by other processes. And knowing all this, it will send the right tasks to the right crawlers, making sure that the workload is very well distributed and also scales up the workloads of each crawler automatically based on its conditions. Now, this was a big change, like a really big change. So we had to make sure to do a lot of testing, because after all, if this thing didn't work, none of our shops would succeed, and that cannot happen. So besides the regular unit test, we also had like traffic emulators, allowing us to test different components in isolation. We did something other as well. We tested the new system together with the old system in parallel, allowing us to compare the outputs and knowing more or less that these two systems generate the same outputs. They work a bit different, so it's not a one-to-one mapping, but it definitely allowed us to be sure that we could move forward to production. And with this being said, we are ready to see the final infrastructure, which is the infrastructure we basically still use today. So we introduced Splash, but that was replaced by Puppeteer. And finally, we introduced all the new components for the Integrities V2 project, which exists out of a Go process called input-gen, which generates the inputs and stores them in FoundationDB. We also have a brand new Integrities V2 dashboard written by the front-end team and is in Ember.js. We also have the planner, which was in Python. And Then we have the scheduler in Go. We have another, now also a process in between the status updates, while before there wasn't. And our regular Scrapy workloads are now also Dockerized. We learned from all our mistakes and we learned from all the challenges. Each time we had to adapt and we did evolve. And that's basically a process that we still repeat just as well as most of you are probably doing every day. Automation helped us big time in achieving all of this. Monitoring and alerting is one example of this, but another one is incident response, because you never know when a big data source suddenly stops generating data for you. In this case, it will call any one of us up that is on duty. We also have tooling, such as metric exports and dashboards, allowing our developers and other teams to investigate issues very quickly. We also want to learn to be proactive and not reactive. Because when you're reactive, you're only trying to fix the challenges or problems that you face today, and you're basically running behind the carrot. When you're a small startup, you're probably doing a lot of that, but you really want to put yourself in a position as soon as you can to become proactive. We also adhere to a rule called a cost-reward balance within the crawler team. This is important because we are crawling at scale, and so costs do matter. There are different kinds of proxies going from data centers to residential, all the way to mobile and more. And each of them have a different price category. So you want to make sure that you choose the cheapest one that you can get away with for a given data source. Scraping data with a browser is also pretty easy, because most of the time it will get you already most of the way. But it's also the most expensive solution. That's why most of our data sources are being scraped using Scrapy. And not only Scrapy, we have, of course, also our entire own framework around Scrapy. But what I'm trying to say is, if you don't need the browser, then don't use one. Everything can be automated, but not everything should. That's another one. And of course, I see a lot of people in the industry trying to solve CAPTCHAs. But what if you can prevent seeing these CAPTCHAs altogether? It's even cheaper. Now, today, the landscape has changed a lot. We see a lot more aggressive bot detection and fingerprinting. We also have more and more needs from our business. And so we are hiring and educating our team as we speak. We're also improving our user experience by upgrading our frameworks that exist today and replace tooling that needs to be replaced. We are researching and development a lot related to our proxy and networking tools, as well as our automated browser solutions, because the web landscape of tomorrow is not the one that we started with. If you want to be part of this team, you can also join us. You can visit this website as displayed here and be part of our journey. I hope that the lessons that I gave you today help you and your team to solve the challenges that you face every day. And if so, you can always reach out to me if you have more questions. Thank you very much, Oxycon, for listening today to my presentation.
Well, good job, Glen. I can tell that the viewers really enjoy your presentation, as we have many questions over there. And indeed, it was interesting to see how your company evolved over the time and how you continuously solve the problems and tackle them in taking into account the scale. So, dear viewers, we will again kindly ask you to rate Glen's session. Let us know how did you like it. And so let's now move on to questions and answers, right? So the first question is, how do you manage the blacklisted proxies?
So blacklisted proxies we manage in several ways. One way is by temporarily not using them, which we can do thanks to the overview we now have with super proxy and all our monitoring. And then basically try to figure out, of course, why we are getting blacklisted. Because if you just would immediately try to switch to a new proxy, you're just going to get blacklisted with them as well, potentially. So only once we figure out why we're getting blacklisted, we're also actually going to switch or unblock it.
All right, okay. The next question is, why have you chose protobuf over JSON?
I think basically you could get away with both, but protobuf is a bit more efficient and worked well with a lot of other infrastructure. It also allows you to get a very structured and typed schema for your data, which is very nice to have as a contract between different processes. While with JSON, that's less built in.
Okay. Svetoslav has a question. How do you implement proxy rotation HTTP with authorization for Puppeteer?
Okay. So, well, for us, it doesn't matter if the data or rather the request comes from Puppeteer or it comes from Scrapy. Either way, it goes via super proxy, which sets up a session per use case, or let's say per incoming connection. And so it chooses a proxy based on the given properties it requires, would be like which country, which kind of proxy, and it will only rotate once it fails. And it will basically, for any new session, pick up any random proxy with a good enough reputation within our set of available proxies for those kind of properties.
All right, okay. I have some additional questions. How do you see your infrastructure evolve in the near future?
Okay, so when we designed the entire DSV2 concept, we really designed it to be ready for the future. And today we still see that it still can handle our load. So on that end, I don't see an immediate change. What I do see changing and what is changing is our proxy infrastructure as well as our automated browser solution. Puppeteer was never made for scraping purpose, but more as a testing tool. So we are moving away from that, but that's still in progress. And our super proxy was written in Go, which was very nice as we already knew Go, but it's not very nice for all the niche things we have to do. So we're also moving away from that project and setting up a new one. The landscape in the meanwhile changed as well. There is HTTP2, there is HTTP3 in the future. There are new TLS versions, so a lot of new things we have to be able to handle in order to not get detected.
Okay. Another question, why did you roll out your own proxy service?
Because basically in those times, and I still think today, there was nothing that was able to handle the load that we had to handle today, including all the different customizations that we had to do. It's one thing to use some kind of proxy that just does some basic monitoring, but once you want to do a lot of custom middleware in between, that's not something you're able to do with build off-the-shelf solutions. So I think once you're at that stage, you have no choice but to go for your own solution.
All right, totally makes sense. Why you use your browser as an API versus its own crawler with a queue?
That's a good question. Basically because it allows us to still utilize our entire Scrapy framework while just making sure we use the browser for the data we need. It also allows us to make hybrid solutions. Sometimes using the browser, you only need sometimes to get some kind of session cookie or some kind of intermediate request, and then you can move on to Scrapy once again. So we really try to use the browser as little as possible. So for us, it makes no sense to have its own workloads, and it will also be less convenient for our developers.
All right. There's another top question from the audience. Will there a recording be available afterwards? Absolutely. Probably people just want to rewatch your presentation again. That's a sign that they really like the content. Another question from the audience. Are you using Puppeteer for scraping?
Yeah, so at the moment we are using Puppeteer. We used to use Splash, but since 2017 we use Puppeteer. It's still a very old version, and we are not using any kind of plugins or other systems in the ecosystem, but we did build a lot of customized stuff around it ourselves. Basically, there's an entire framework around that we build ourselves, and that's what we still use today, but we see a lot of limitations with it, and we are getting detected by more difficult data sources. So that's another reason why we really need to urgently switch to our new projects, which is in the pipelines.
All right. Moving on. and I just gonna quote, separation of extraction and transformation is nice, but do you run this immediately or trigger the request after extraction and transformation is completed?
Okay. So our crawler crawls the data, and as soon as it has the data, it sends this intermediate data over well, now PubSub used to be Kafka, to a transformation stage. So it's pretty much triggered immediately after the crawler stage. At the same time, we are storing this intermediate data format also in a temporary file storage, which now is a BigQuery. And so we could also re-trigger it manually ourselves afterwards. But the initial transformation phase, and hopefully the only one, is triggered immediately and automatically by the crawler sending the data as soon as possible over to the transformation stage.
Okay, another very similar but technical question. How do you handle transformation needed for the extraction so the next request URL is dependent on transforming extracted data?
Okay. So because we use Scrapy, we can rely on this concept called metadata, which is something you can attach to a request. And so any data we need to keep in mind for the next request, we can also store in this metadata. At the same time, we also make sure to use the same kind of cookie jar, use the same kind of session for our proxies, so that we're also each time going through the same kind of proxies. So I think that's how I would answer that question. I'm not sure how the transformation stage is related to that.
Yeah, guys, if you will have any further questions after this presentation, again, you can use our dedicated Slack workspace, and if there's some additional details you want to check, you will be able to ask those questions over there a bit later. All right, another question, as we have really a lot of them. What is the dashboard we saw in the integrity slide? I have seen it during another presentation before. Not sure if you recall that.
Yes. Well, it's customized made, but it's basically just a table. So I can imagine that you see many tables in your life before. The dashboard, however, is made by a front-end team in-house. And what it shows is per time zone and per data source is the success rate of those kind of batches. If you hover over it, which I couldn't show in this GIF, is that you will also see which integrity is completed, which congruity, etc. You can then click through those different cells and get through the different dashboards that you saw on the right of the slides, allowing you to see also the planning and seeing over the last 24 hours what completed, what is scheduled, what is planned, etc. You also see clearly when it fails and so on. And from there, you can go deeper and deeper into the pipelines.
All right, moving on. If you could mention the OSS tools that help you, it would be really helpful for some of us.
Yes. Well, Scrapy is by far the biggest OSS tool that would help us, I imagine. It was there since the beginning, and we still use it happily today. We did learn a lot since then. In the beginning, we didn't really know very well how to design middleware that works well with Scrapy, and so there were hard lessons we learned later. In the meanwhile, we have an entire framework built around Scrapy, but Scrapy is still at its core. And other technologies, or well, the languages themselves basically, but everybody's using those like Golang and Python, all the G Cloud utilities and tooling, because by moving to the cloud, you're already getting a lot of tooling. Well, I wouldn't say for free because you do pay for it, but at least you don't have to develop it yourself. Yeah, I think those are the most important ones.
All right, guys, take a note. Moving further, do you perform some kind of SSL fingerprinting? Do you have any advice for other engineers around this topic?
Yes, but weirdly enough, this wasn't really required until I would say the last year or so. Like most data sources were not that reluctant to check the TLS layer. They would check the HTTP layer since a long time ago, especially on the basic level. But actually seeing them checking the TLS fingerprinting was a pretty new thing, despite the research being quite old. So we do now also emulate that, meaning that we have to emulate the different packages sent on the TLS layer based on what kind of user agent we are saying that we are. So, and that's something that happens within our proxy technology.
Right. We have another high-rated question from Fabian. What will be your next challenges in terms of bypassing anti-scraping protection? I saw fingerprint, but what are your next priorities?
Yes, well, I labeled it on a fingerprint, but that's basically what it's all about. They try to do a lot of different tests and see if who you are, that you really are. So, as I said before, we are now focusing mainly on our proxy technology as well as our automated browser solutions, because we see more and more aggressive bot detection. And so this means our proxy need to be able to handle HTTP2 very well on a very detailed level, because depending on the user agent, it can have a very different kind of signature in terms of traffic. We need to emulate all the different network layers very well. And we also need to step up our game in the browser space, because they can do a lot of different tests in the browser space, which is only really a problem for those data sources that require it, but there are some. And so focusing on our automated browser solution is another big priority for us. So yeah, the proxy and the browser, that's what I would say.
Okay. Another question similar to this. How do you avoid CAPTCHAs?
Well, basically, sometimes you can. Sometimes some websites really have a very aggressive setting and they will always show you a CAPTCHA. But those are really rare because users do not like CAPTCHAs. So most of the time, they only send CAPTCHAs if they already think you're suspicious. This could be because you're sending too much traffic to a certain proxy, or because your fingerprints don't make sense at some kind of level or multiple levels. Then there are also websites which send background CAPTCHAs, and those are used first, and in case you solve them, only then you would get like a real CAPTCHA. And those background CAPTCHAs you can often already solve even within Scrapy if you apply some reverse engineering. It's only when you're really unlucky and there's like a very aggressive bot detection which always gives you a CAPTCHA in a fresh session for a new user that you cannot really get around it. But so far, I only know of one data source in our case which applies this.
Okay, thank you for your answer. Next question. What was the best improvement you noticed when you moved from scraping from virtual machines to Docker?
Yes. So, well, basically, having these scrapies in Dockers was never really the goal in itself, but more a need for the things we want to do. And so for live shops, it was a requirement, because if we would still have to use virtual machines in that case, we had to have these ready all the time, because we don't know when we need them, which would mean that we need to have a lot of capacity used for nothing, which is not what we want, because we want to make sure that every resource we pay for, we also use to the fullest. So that's something you can do with Docker, because you can easily spawn more containers, either by just using the resource-based approach, which is something most cloud providers provide, including G-Cloud, but also allowing us to scale it automatically yourself. So I think, yeah, if I would say one thing, it would be the fact that you can scale very easily, and automatically.
Okay. I think you touched on this, but since this is a high-rated question, again, just a moment, I'm sorry. Yeah. How do you have you considered using Playwright instead of Puppeteer?
Yes. We are actually, as a team, constantly researching and development. We are constantly researching new tools and everything that's in the market. So I would be surprised if there's a tool that I don't know about yet. And Playwright was one of them. It's pretty similar to Puppeteer, but once again, it's made for testing purposes and not really for scraping, so it doesn't really solve anything that Puppeteer doesn't solve for us. Instead, we really want to go for an approach where we build a solution not from the ground up, but definitely have a way to interact with the browser and really with scraping in mind. And that's something both Playwright and Puppeteer do not allow us.
Right. And the last one is not a question, but a comment. Thank Glen for your presentation, super helpful.